So what is a quadratic? And we're going to look at some sequences and graph them so that we can understand a bit more about what a quadratic is. This first sequence goes 1, 3, 5, 7 and 9. I'm going to plot it now. I knew where to plot that because I've got my x values, 1, 2, 3 and 4 are the numbers of the terms, and my y values are the height. So 1, 1, 2, 3, 3, 5 and 4, 7. And when I join those up, I end up with a straight line. And it's a straight line because each term goes up by the same amount. Each term increases by 2. So I know the next term in my sequence, the fifth term, which will appear here in my graph, should be 2 more, which is 9. So the fifth term is 2 more, that's 9. And we call those linear sequences because when we draw them, we get a straight line. Now this type of sequence, you might have noticed, doesn't go up by the same amount each time. Rather, it's going up by, getting faster and faster. It's increasing more and more. So let me plot this one now. And again, I knew where they went because the x values are the numbers of the terms, and the y values are what the terms are themselves. So 1's 3, 2's 6, 3's 11, and 4's 18. Now, if I see that, that's not a straight line, but rather it's a curve that goes round like that. And it's getting steeper and steeper and steeper. And we want to know what the next term is, what the fifth term is, where it is on here. We can probably try to guess that from our graph, but how we do it from our equations, we'd say, well, from our points, it goes up by 3 here, 5 here, and 7 here. So how might it go up there? Well, it's increasing by 2 each time, the amount it's increasing by. So here, it's also going to increase by 2. 7 plus 2, which is 9. 18 plus 9, which is 27. So this point here should be 27, which is here. Which looks about right on our graph. We call those quadratic. Call those quadratics. So we can tell it's a quadratic because it's increasing in this curved way. It's faster and faster and faster. The second difference, the second row of differences here, is increasing by 2 each time. And if that's the same, it could be any amount. It could be 1, 3, 5, half, whatever. As long as this second difference is the same, it's going to be a quadratic. Here it's a linear because it's increasing by the same amount each time. And that's the difference between a linear and a quadratic.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.